So type of semiconductors based on their based on the charge carriers, and purity. Based on this, we can classify semiconductors into two. First is intrinsic semiconductor, and extrinsic semiconductor. So the normal semiconductor which is available in the elemental stage, the naturally available semiconductor like silicon and germanium are called the intrinsic semiconductors. Let's see what is intrinsic semiconductor and what is the energy band diagram. So intrinsic semiconductor. A semiconductor in the most pure form is called intrinsic semiconductor. That is, the semiconductor in the most elemental stage. In the elemental stage, or as the element, is intrinsic semiconductor. Conductivity of this kind of semiconductor is very low. Conductivity of intrinsic semiconductor is very poor. As you have seen, the energy band diagram of normal semiconductor is exactly what is that. So at 0 Kelvin, intrinsic semiconductor like silicon, germanium is an insulator, and at room temperature they are conductors. Free electrons at room temperature break bonds covalent bonds, getting energy from surrounding temperature, and jumps to the conduction band. We have seen this. So energy level diagram, exactly what you have done. So we will be having at 0 Kelvin, for intrinsic semiconductor, you see at 0 Kelvin the valence band is completely filled, The valence band is completely filled. Now I'm going to show with this thing, and the conduction band is empty. So this is at 0 Kelvin. As temperature now rises, surrounding temperature rises, the electrons get thermally agitated, they get excited, and they will break covalent bond. And as they break covalent bond, then what will happen? Few of them will start. The free electrons will now break the covalent bonds in the valence band, and then will jump from here to the conduction band. So you'll see these are different levels. So electrons from here, there is a one gap, and electron will jump from here to here. They will jump. Similarly from here empty, maybe someone from here will go to this, and so on. So they will start making the jump. That is at room temperature. Now if we show the bond structure, now here we are going to get introduced to the bond structure of intrinsic semiconductor. So let's take silicon. So here is silicon. This is another silicon atom. The valency of Si is 4 plus 4, so they will form covalent bond like this. So you can see these are different covalent bonds. I'm not showing that side anymore. And here one. So we're going to have the covalent bonds, we're going to have the dots. So maybe 1, 2, 3, 4 and so on. 1, you can show it here also, or you can show it here. I'll show here. I'll change this diagram again in another way how to draw it. So here you can see, oh sorry, I did not draw it here. 2, 3, 4. So this electron is exchanged between the two atoms to form the covalent bond. They share to form the bond. So this is it. This is the bond structure or bond diagram. You can imagine you are seeing bond diagram of bond structure of intrinsic semiconductor. Semiconductor. So the conductivity is very poor, no use. You cannot use it for any other purpose. I will see extrinsic semiconductor.